Welcome. So in previous class we were discussing that questions and answers, and I think we have stopped in these questions. So what is say that these questions that heat is given, and first our work is to count the number of pi bonds. So how many pi bonds are there? 4 pi bonds are there, and we know that this 4 means even means that is 4 pi systems, and 4 pi, and that is on heating. So 4 pi heating, then the earth will be on cold rotatory, new bond can form. Okay, so that we have discussed in the previous class. So what I say that in core, it means that stereo will change. Stereo change. Okay, so now these four pi systems, what is seen here, that how the movements will occur. So it will move to here, and this is going to move here, and this is going to move here, and this is going to move here. So if you confuse that, then you can simply make that positive and negative. So if it is moving here, so this is positive and this is negative. 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 And what we know that positive negative make bonds. So make that, and what we see here, note that this positive negative, just for understanding I am making, but this positive negative will not form while doing the reactions, because what is say that pericyclic reactions will go through a transition, that is cyclic transition states. So simply for understanding I am making this positive negative, okay, to understand that where the bond can form. So this positive negative will bond will form. So this will going to be like this. Response. So this is going to shift here, and this is going to shift here, and this is going to shift here, and this is make this bond. So this bond has newly made. This bond is newly made. This sigma bonds. So now that where the bond will made, on that bond, that stereo, okay, not stereo, stereochemistry will be defined where new sigma bond or sigma bond break. Okay, so here the stereochemistry will depend. So wherever that either that new sigma bond is forming or that sigma bond is breaking, so on that the stereochemistry will depend. So here these two carbon atoms, here that stereochemistry, here that bond sigma bond has formed. So these two carbon atoms, here the stereochemistry will depend. So stereochemistry will be defined where new sigma bonds form or new or sigma bond breaks, means the two carbon atoms, because one bond will form by two carbon atoms. So the two carbon atoms where sigma bond break or form the stereochemistry will be defined. Okay. So here what that this is the new sigma bonds, and these are the two carbon atoms. Here the stereochemistry will depend. So for that, what we look that initially how the stereo is between these two carbon atoms. That what you see that for that what you look here. This is that double bonds. So this is here. This is here. So this is in trans. Okay, and now this is also on according to this double bonds. This is here and this is here. This is also trans. So after that what it will become, so since this is a cone rotatory, so this is going to be the trans to, it convert to cis, it means that the two carbon atoms will be in the cis. It means one is above, then other also has to be the above. Okay, but what we say that this is a 8-membered ring, and 8-membered ring is not so stable, so they wants to convert into that stable member, that is maybe 6-member or 5-member. So what we see that this also not that 8-membered rings are not stable, so they convert to stable 6 or 5-membered rings. Okay, so this is now again the heat, you are giving the heat, then what will happen that this will convert into a 5-membered ring. So for that what we do, that again do the rotations here. So this will rotate to here, this is rotate to here, and this is going to like this. So 6-membered rings will form. So see, this is positive and this is negative, and again this is positive, this is negative, because electron is moving, and this is positive and this is negative. Not that I am saying again and again that this positive negative, just for understanding, but this will not form in a pericyclic reactions. Okay, so look that 6-membered ring. So this is 1, 2, 3, 4, 5 and 6. So this positive and negative make bond. Okay, so that will be going to be like this. Okay, so this is going to be like this, and this is shifted to here and this is shifted to here, and another is 4-membered rings, 1, 2, 3, 4. So another is 4-membered ring has 4. Okay, 4-membered ring has formed. So this is the new sigma bond is formed. So new sigma bond is, this is the new sigma bonds. So that new sigma bonds, so these are the two carbon atoms. Here that stereochemistry you will define, because the new sigma bonds on that two carbons, the stereochemistry will define. So these are the this is the sigma bonds, new sigma bonds formed. So two carbon atoms are, these are two carbon atoms, these are the two carbon atoms. Okay, now here we will define the stereochemistry. Now since here that both are hydrogen atoms are there, so since both are hydrogen atoms, then there may be cis or there may be okay, so 1, 2, 3. Okay, only one hydrogen atoms is there. So okay, sorry. So now what will be the stereochemistry of that hydrogen atoms? Since here how many pi bonds are involved? 3 pi bonds, and 3 pi bond means odd. Odd means 6 member rings, and 6 member rings on heating means it will be disrotatory. Now what we look that here, we look that hydrogen atoms in which set, are they are in cis or trans, that we look. But thing is that here this is in the double bonds, these carbon atoms where that new bond has formed, this is the double bonds was there, and we know that this double bond, okay, this is the sp2 hybridized. sp2 hybridized means these are the planar systems. So the planar systems, if that is a planar, means that hydrogens will be if it is a planar, then hydrogens will be also in the plane. It means that there is no stereochemistry for a planar systems, because the systems itself is a planar, so that hydrogens also in the plane. Okay, so here above or below that things we will not define, because they are in the planar systems. So here we can say that hydrogens may be they will be either maybe these sides, because that we will not define that, because here that is we don't know whether this is cis or trans, because they are in the planar systems. So this may be hydrogens or this. Okay, or we can say that this also can possible. this is the hydrogens, and this is the hydrogens, because in that case they were in the planar systems, and from the planar systems that hydrogens that above or below that can be defined because that atom itself is a planar. Okay, so that's why that hydrogens can be here or like this. Because if you know that here cis and this is the trans, on that case we can say that this will be that and that will that, because you don't know this the stereo of this carbon atoms. So accordingly we choose the options. Okay, so this is the answers for these questions, okay, now moving to the next questions. So in these questions, what that 8-membered ring is there. So what I say that 8-membered rings are not stable. So they want to convert into the 6-membered ring. So what they will do that this will rotate like this will rotate, and see that, and this is also rotate like this. So then what you see that this is positive, negative, positive, negative, positive, negative. So count the number 1, 2, 3, 4, 5, and 6. So this 6-membered ring will form here. Okay, because this is negative and this positive make bonds. So 6-membered ring will form. Okay, it means that these 6-membered rings will form here. That is 1, 1, 2, 3, 4, 5, and 6. And after that, how many? 1, 1, 2, 3. So this 4-membered rings is formed again here. Okay. So and this double bonds is shifted to here. One is shifted here, another is shifted here, and this has make the bonds. And one double bond is here itself. Okay. And what is that here? What is seen that here that is formed here. So again, what you see that this is in that previously this is in the plane. So this is sp2 hybridized. This is sp2 hybridized. It means that carbons is in sp2 hybridized means that hydrogens itself is also in a planar. Okay, so that stereochemistry will for this new sigma bonds form. Okay, here the 2 carbon atoms here which has to depend the stereochemistry, but since that it is in the planar, because you don't know that stereo of that hydrogen atoms in case of planar system, so we can define simply that hydrogens here. So that we choose according to the options. It is above or it is below. Okay, because stereochemistry we don't know since this is the planar systems. Now what happened that after hitting this is already 6-membered rings and this is 4-membered rings, so that it will stop from here because this is already stable. Okay, because if it is break again, let's say if you break and if you make again that says this is plus minus and this is plus minus, if you make the 4-member rings, then this is going to be formed like this, which is not stable. Okay, because that 4-member rings they have the angle strength, so this is not convert to here, so it will stay as it is. So this is the final answers for these questions. Okay, so moving to the next questions here. So this is a very important questions now. So this is the 6-member rings and 4-member rings, and we know that this 4-member rings means they have the strength. Okay, so now what we'll do that this just write this one. So here, and this one I can make here also. Okay, now this is like this and this is like this. Now what I do now is I can move this one to here, I can move this one to here. Why this sigma bond has break here? Because due to the angle strength, because 4-member ring is not stable. 4-member ring not stable due to angle strength, so that's why this sigma bond also will break by if you give the heat. Okay, not stable due to angle strength. Okay, so this is also break. So how many pi bonds used here? We can say that one pi bonds. No, here two pi bonds will use. Although this is a sigma bonds, but whenever you are counting the pi bonds, we will say that this sigma bond also count as a pi bonds. So here two pi bonds will use. Okay, two pi bonds, not one pi bonds, because due to angle strength, this is also a weak sigma bonds. So whenever you are counting the pi bonds, on that time count this sigma bond also as a pi bonds. Okay, so not if I make that in this case, in this type of questions, count sigma bond also pi bond. Okay, because this sigma bond is a weak bond due to the angle strength. So 2 pi bond is huge, it means that this is even. So for pi systems. Okay, now just make it. Okay, so what I say that we will make the stereochemistry, we define the stereochemistry through that sigma bonds. Either it may be breaking or it may be forming. So in this case, this sigma bond is breaking. It means that here we will define the stereochemistry. Okay, so if I write it, then how it is going to be like this. Okay. So this bond has break. So one is comes here, another is goes to here. Okay, and this is break. It means that these two carbon atoms here, that bond has break. Okay, so now we will look that what is the stereo of this carbon. So here this is above and this is below. It means that these are in trans. These are, because the one is above, one is below, it means that this is trans, and we are giving heat, and this is that cone rotatory for pi systems. So this is cone rotatory, and this is 4 pi system, so that will change into cis. It means that here we will get that cis product. It means that one will be like this, then other also has to be like this. Why? Because they are cis, means both are trans. Let's say to this double bond, this is trans, this is trans, that is cis. So this is the cis. Okay, and here we have this type of bonds. I can give. Okay, so since this is the trans, so trans will convert into cis, and cis means what we say that trans, and trans is actually cis, or cis is actually the actually cis, and if trans and cis, that is going to be the trans. So you make this trans. So what I'll do for that, I will make both trans and trans, because for to this double bond this is trans, and for this double bond this is also trans. Trans means cis, so this trans to cis it has convert. Okay, now what I have to do now, next okay, so this is the answers for these questions. Okay, this is the answer. You check the options if it answer should be this one. Okay, why? Because alternately you can check also that if you give the heat, then this is convert to this one. We can check it. Okay, how it will, let's say this is going to shift it here, and this is going to make the bonds. So that is going to be like this. Okay, so that is shifted, this is already there, this is shifted, and this is going to make that 4-member rings. Okay, that is shifted, this is become, and since this is trans and trans is, so this become the trans means that is one is above, then one has to be the below. So from indirectly also you are getting this one. Okay, so we can check that alternative way. So this is the final answers for these questions. Now moving to the next questions. That is this system. This is 9-member ring. So this is very unstable. So first we will look that how many number of pi bonds are there. So here how many number of pi bonds? Three. So 3 pi bonds. 3 pi bond means 6 pi systems, and we are giving the heat means that is going to be the this. On this it will make the bonds. So first we will do that this. So how that it will rotate like this and this. For that we will make positive negative positive negative positive negative. Okay, so 6-member or 5-member are the stable, so it will make 6-member ring. So 1 2 3 4 5 and 6 means positive negative make bonds here, and this is again in the planar systems. So the stereochemistry is either that is not depend here, since because this is also again become a planar system. This is sp2 hybridized. Okay, so here new bond is forming. So where new bond is for that carbon, that 2 carbons, the stereochemistry will define. Okay, so that is going to be like this. 6-member rings. This form the 6-member rings, and this is going to be like this. Here that 2 carbon atoms, where that new sigma bond is formed, and here we have to define the stereochemistry. But since this is a planar systems, because both the carbons are sp2 hybridized, so that hydrogens, the stereo of hydrogens we don't know, so we simply write this one that we choose according to the options. So let's say I am writing this one, or we can write below. So whatever the stereochemistry mentioned in the options, we choose that, because this is the planar system, so we know that we don't know the stereochemistry of this hydrogen atoms because they are in the planar. So because this 2 sp2 are the planar, so the hydrogen also planar. Let's say if one system is like this plane, then that hydrogen atom also will be the in the plane. Okay, that hydrogen atom also will be in the plane. So on that times we don't say that that is whether above attack or below attack, because both hydrogen atoms are in the plane. Okay, so that's why we say that it can be, we don't know the stereochemistry, so we can write either above or in the below. Okay, and this is 5-member rings. 1 2 3 4 5. So 5-member rings we will make here. So 1 2 1 2 3 okay, 5-member rings is made. Now what will do that, yes, so this is the final answers for these questions, because this is already a stable rings, so no more things will happen. So this is the final answers for these questions. Okay, because this 8-member rings breaks to form a 6-member rings, and in the options that is going to give like this. Okay, this will, they will make that 6-member rings, and they will make that 5-member rings. So somehow they will like this, and that hydrogen atoms will be here like this, or it may be like this. So anything they can mention, so like that we can choose the options from that. Okay, so now moving to the next questions. This is again a 8-member ring, so that is not stable, so this is going to break. So first we look at how many pi bonds are there. Okay, so here that 3 pi bonds means 6-member rings, and on heat, so it will form bond on this, means that stereo will not change. Okay, whatever the stereo that will make. So just break the bonds. This is going to like this is set, and this is going to make like this. This is positive negative, this is positive negative, and this is positive and negative. This is the positive. Okay, so 6-member ring will form, that is 1 2 3 4 5 and 6. So here that bond will form. Again this is a planar systems. Okay, so that is not affected. So that is going to be like this, and this is going to be like this, and this is 1 2 3 4. So 4 member ring will form. Okay, so this is going to be that methyl, and this is going to be that this methyl. Okay, so this is that form. So this is again 6 member ring. So here we have to depend this, we will not do, because that we will depend the stereochemistry that the new sigma bonds form, or that the sigma bond that is break. So here this is not involved in our bond making and bond form, that new sigma bonds break or sigma bonds form. This is not involved, so that stereochemistry is as it is. Okay, they just mention this to make you confused, but our work is to define the stereochemistry over here, which that new sigma bond is formed. So these two carbons is involved in making new sigma bond. So here the stereochemistry will define. This is not involved here. So this we will not look that whether this is trans or cis. We don't care about it, because our uh, attentions will be that carbon atoms, that two carbon atoms where that new sigma bond is formed, or that sigma bond is break. Okay, so here that these two carbon atoms are involved in making sigma bond. So here stereochemistry will define. So since these are in the planar, so this also becomes the planar. So this is a become planar. So we don't know the stereochemistry of that hydrogen. Means that two hydrogen atoms are in the plane. So we simply write this. Okay, this that will remain as it is, because we don't know about it, because we have no work with this to methyl. Okay, now moving to the next questions. Sorry, now moving to the next questions. Okay, this question. So here everything is fine. That is inside that. Okay, here that double bonds is here. These have this double bonds. Okay, so this is the actual questions. So now in these questions, what we say that here this double bond is not in conjugations. So what I have said in that electrocyclic reactions, that substrate has to be in the conjugations. So this double bond is not conjugation, so this is not involved for now. Okay, so which is that this is involved. So this one also I can write like this. So that I can write like this, and this is here, and this is going to be like this. Okay, now that it is given, this one also I can write like this. Okay, now that this four member ring is has the strength, has angle strength, so unstable. So what it will do, that it will break this bond. So this is going to like this, and this is going to break. It means that here how many number of pi bonds are involved. So that here total is 3 pi bonds, but our work is that how many pi bonds are involved in the reactions, that we have to look. Okay, we will not look that how many total. So how many pi bonds are involved here? This is one pi bond, this is involved. Another is this sigma bond is breaking. So that I say that whenever that sigma bond is breaking, or this is for me on that time this is breaking, so this one also I count as a pi bond. So two pi bonds has involved here, not these three. Okay, it's because these are not involved now, only these two are involved. Okay, so this sigma bond also I consider as pi bonds, and I says that two pi bonds are involved. So this is even, so 4 pi systems, and that is con. Okay, so 4 pi, and if we hit, then that is con, means that stereochemistry is going to change. So which bond is breaking? So this bond is breaking. See that this bond is breaking, means that it has to depend the stereochemistry of these two carbon atoms. Okay, so just make that. So this is as it is. Okay, and this and this. So this is coming to here, and this bond is breaks, and that is also comes here, and this is remain as it is. Now that where that carbon atoms is involved, this sigma bond has break. Okay, so these two carbon we have to define the stereochemistry. So how will you define the stereochemistry of these two carbons? So see that if you look it carefully, that it has that here what is there, no double bond is there. So here we have that hydrogen atoms. Okay, two hydrogen atoms are there. Here also we have that one hydrogen atoms. It means that the stereochemistry will be because here double bond is not there, so cis trans we can't define. So we simply write like this, because the double bond is not there, so we can't say that whether it is cis or trans. Okay, because this has breaks here. So in these carbon atoms there is no double bonds, so we cannot say that whether it is cis or whether it is trans. So for saying cis and trans, we have to say with respect to a double bonds. Okay, because cis and trans, that will done with respect of double bonds, but here no double bond is there, so you can simply write like this. Now what you do, that again heat is there, so what that now this is again they will do like this. Now how many pi bonds will involve? Look that. So now the 3 pi bonds are involved. 3 means odd, odd means 6 pi systems, and that is heat. Then that is going to be the dis rotatory. Okay, so now we understand, you can write positive, this is negative, this is positive, this is negative, this is positive, and this is negative. It means that this and this will make bond. Just count 1, 2, 3, 4, 5, and 6. 6 member ring will forms, and this new sigma bond is formed along this. Okay, along this, that new sigma bond is going to form. So for that, here sigma bond is formed. So it means that we has to say that stereochemistry we have to define here. Now what we see that, okay, so this is the double bonds. Now double bond is there, so we can define that cis and trans. So now if it is the double bonds, then what we say that this is here, this is here, here we have that methyls, and here we have that hydrogen atoms. It means that this is in the trans. Now in this double bonds, okay, so this is here, and this is here, and here we have that hydrogen atoms. So this is again that is again, this is also a trans. Okay, this is also again going to be a trans, because we see that this double bonds, this is going to be trans, and this is also going to be a trans. So what we say that here, what we look that 6-member ring will forms, 6-member rings will forms, and here 6-member rings forms here. Now here this is the, so this is shifted to here. So make that 1 2 3 4. So I can make here, this is 5, okay, this is 4, and this is 3, this is 2, this is 1, and this is 6. So this 6 and 1 make the bonds. So this is the bonds that is made. Okay, now 2 and 3 they have the bonds, double bonds, and 4 and 5 they have the double bonds, and this is the what the bond has formed. Okay, so now the stereochemistry, here we have to define, here we have to define the stereochemistry. Since this is the base, so that is, let me see that. Okay, so since that here double bond is there, but the thing is that this is that there, but here no methyl is there, so we can't say that cis and trans. So here also we simply write like this. There is a stereochemistry we can't define, because if we have that methyls here, then we can say that this is trans to it and this is trans to it if we have the methyls. Okay, but here we don't have methyl, we have that hydrogen. So that stereochemistry again we can't define here. So the final product is simply this one. Okay, now moving to the last questions for this electrocyclic reactions. This is the last questions and very interesting questions. So this questions, what is that? 6-member ring is there and 4-member ring is there, and that is the inductance, and here stereochemistry is mentioned. Okay, so look carefully these questions. So I will solve it. So this one I can also write like this, heat is there. Okay, so this one I can also write like this. So yes, this one, here we have that 4-member rings, that double bond I can write here, and this is in the okay, so this is the above and this is the thing down. Okay, and here what we have that this is like this, here we have that methyls, here we have that methyl, and this is like this. Okay, now we have to give it, I just erase it, this one. This is a very good questions. We will understand the stereochemistry here that clearly. Okay, so what we will do that if you are giving the heat to it, then what will happen that this will go and this will break, because this is a 4-member ring and angle strain is there. So how many pi bonds are involved? 2 pi bonds. These are not involved. Okay, so 2 pi bonds means that is even means 4 pi systems, and going to hit, that is going to become a conrotatory. So do that. Okay, this one and this one. Okay, so this is x, so this is going to be like this, and this is comes here and this is goes to here. Okay, now through this sigma bonds has break, it means that these 2 carbon atoms were involved in the these 2 carbon atoms were there where the sigma bond has break, means stereochemistry we have to define in these 2 carbon atoms. So what the stereochemistry is there in previously, So if we look here, then what we see that this is in the trans, this is above and this is the below. So this is what I say that okay, so this is above and this is below, so that is out, I can say out and in. So out in, that is going to be the trans. Okay, now if it is trans and if you are doing that cone rotatory, then that is going to be the cis. Okay, so why I will say that this the stereochemistry they mentioned here. Okay, so since they mentioned the stereochemistry and this is above and one is below, that I can write out and out and in, that is going to be trans. If in that is going to be cis, or out that is going to be cis, but out in that is going to be trans. Now this is heat, then that is going to change into the cis. It means that these two will be in the cis. Okay, so that cis means that I can write both in that out, that I going to write like this. So that I want to both in the out. This one also I can write like this. Okay, because this is the cone, so that was this was in the trans, so I make it into the cis. Okay, so I make it the cis. Now what will happen? Here we have the double bonds. So now these double bonds are in the conjugations. So again I can make the bond, that is I can make this one to rotate here, this one I can rotate here, and this is I can rotate here. It means that this is plus and this is negative, and this is plus, this is negative, and this is plus, this is negative. So this plus and negative make bonds, so that I can write here. This is 1, 2, 3, 4, 5, and 6. So 6 member ring will form. So here this will make the bonds. Okay, this carbon and this carbon will make the bond. Now what is the stereochemistry of this? So here we see that this is the double bonds and both that is in the towards the double bond, so this is in the cis. Again now this double bonds, this is here, another here, so this is trans. So this is cis and this is trans, this double bonds. So here we have to look the stereochemistry, these two carbon, because these two carbon atoms are going to make the bonds. So look here, this one, and 6 member ring is going to form here. So naming that 1, 2, 3, 4, 5, 6. So I can name like this. This is 4, and this is 4, this is 5. Okay, and this is 6. Then this is 3, this is 2, and this is 1. So this 1 and 6 make the bonds, and 2, 3 will make bonds. 2, 3 and 4, 5 will make bonds, and this has make these bonds. Okay, so here we have to mention the stereochemistry. So what things we see that this is in the, this is cis and this is the trans. So one is cis and one is trans. So cis and trans, that is going to be the trans, and since this is the we are giving the heat, and this is 3 member ring, 3 pi bonds has involved. So 3 pi bond means odd, means that 6 pi systems, and that is heat, then that is going to be that this. On this they will make bonds, and this means that the stereochemistry will not change. So here also that is that 2, this here, this carbon atom here, that is this methyl is there and this carbon methyl is here. So they are has to be in the trans, because that this is the this. So stereochemistry will not change. So one will be like this, so here methyl, then other has to be like this, and this one we will not define, so that is going to be like this. Okay, so this is the final answers for these questions. So in this way we can solve the questions related to stereochemistry. Okay, so today after this we will discuss more in the next class. Thank you.